Hi, today we're going to be talking about inverses. First thing you need to know about an inverse is what is the definition of an inverse. So if I said, what is the inverse of multiplication, you would say division. Or if I said, what is the inverse of subtraction, you would say addition. So basically, when we're doing the inverse, we're trying to find the opposite of every operation in the function or equation. And in order to do that, we have some steps here that we need to follow. The first one says change f of x, g of x, h of x, whatever it may be, into the variable y. If it starts with y equals, then you don't need to worry about this step. Step number 2 says switch the location of x and y. And you're not going to move any of the numbers or powers or anything like that, only the letters x and y. Step 3 says then solve what you have for the letter y. And step 4 says, once you've got y by yourself, we need to have a way to tell everybody that this is the inverse. So we have a notation for inverse that says f to the negative first power, parentheses x. So anything that has a power of -1, you should know that means inverse. So let's go try some problems out here. Okay, so I'm going to start by changing g of x into y equals 1/2 x minus 5. Switch x and y, so x equals 1/2 y minus 5. Now solve for y, so I'm going to add 5. X plus 5 equals 1/2 y. To get rid of 1/2, I'm going to multiply by the reciprocal, which would be 2 over 1. And I'm going to multiply everything by 2 over 1, which is just 2. So 2 times x is 2x. 2 times 5 is 10. And over here, the 1/2 and the times 2 cancel out, leaving me with just y. So y is by itself, put in our inverse notation. So g to the negative first of x equals 2x plus 10. Done. Next one. I'm going to think of h of x as y equals 3x squared plus 2. Switch x and y. So x equals 3y squared plus 2. Subtract the 2 over. X minus 2 equals 3y squared. Divide both sides by 3. X minus 2 over 3 equals y squared. Then to get from y squared down to y, you square root both sides. So the square root of x minus 2 over 3 equals y. So now put in my inverse notation. H to the negative first of x equals the square root of x minus 2 over 3. Done. Okay, last one. So y equals cube root of 4x plus 5. Switch x and y. X equals cube root of 4y plus 5. Okay, the 4y plus 5 is under the cube root. So you can't move anything or divide anything until you get rid of that cube root. So I'm going to start by cubing both sides. So power of 3. So x to the third equals, and then over here, the cube root and the power of 3 cancel out. So 4y plus 5. Now I can subtract the 5 over, and then I can divide by 4. So x to the third power minus 5 all over 4 equals y. So now I'll put in my inverse notation. So g to the negative first of x equals x to the third power minus 5 over 4. Okay, next part. On this part, we're going to determine if two functions are actually inverses. And in order to tell if two functions are inverses or not, we have to go back to function composition that we learned in the last lesson. And when we do the function composition, they must simplify down to x. So why is it that they must simplify down to x? Well, here I'm going to go out to the internet and I'm going to go to Desmos. And then I'm going to graph it and then everybody can see why that is. So here's my graphing calculator. Okay, I'm going to go back to example number 1 on A. We had 1/2 x minus 5. So that was my original. And then here's my inverse. We said was 2x plus 10. Now, where would I have to fold the paper so that the blue line and the red line would match up? Well, remember we said if they were functions, they had to simplify down to x. So what if I graph the line y equals x? That's the green line in the middle, and everybody notices, hey, if I fold on that diagonal green line in the middle, the red and blue will match up. So that's why to tell if they are inverses, they must simplify down to just x. So let's go here and let's start our function composition. So I'm going to start by taking the bottom one and putting it into the top one. So 2 parentheses 1/2 x minus 5/2, close my parentheses, plus 5. Distribute your 2, so I get x minus 5 plus 5, and then minus 5 plus 5 cancel out, and that simplifies down to x. If the first one simplifies to x, then you must do it the other way. If it does not simplify to x, then you get to stop and say, no, they are not inverses, and move on. So now let's do it the other way. Let's take the top one and plug it into the bottom one. So 1/2, open my parentheses, 2x plus 5, close my parentheses, minus 5/2. Distribute, and I get x plus 5/2 minus 5/2. And those cancel out, leaving me with just x. So both times they simplify down to x. So I would say, yes, these two are inverses. Okay, let's go to the next one. Okay, so on the next one, I'm going to take the bottom one and put it into the top one. So square root of x minus 5, quantity squared, plus 5. Now here you have to be careful because you should notice that the square root does not go over the x minus 5. It only goes over the x. So you can't just say, oh, power of 2 and the square root cancel each other out. We could only do that if it goes over everything. Since ours doesn't, then I have to think, oh, this means I have 2 identical parentheses. And if I have 2 identical parentheses, I have to multiply with a box, or I can use FOIL. So here's my box. Remember the 2 parentheses are identical. Square root of x times square root of x is just x. Negative 5 times the square root of x is negative 5 square root of x. Then I have another negative 5 square root of x. And negative 5 times negative 5 is 25. So we're looking at x, add my like terms here, which would give me negative 10 square root of x plus 25. And then I still have that plus 5 outside the parentheses. So if I simplify this, I get x minus 10 square root of x plus 30. Well, did that just simplify down to x? No, it did not. So I don't even have to do the other way. I get to just stop and say there is no way that these are inverses. Okay, so let's go to the next one. I'm going to take the bottom one and put it into the top one. So the cube root of x plus 7 raised to the 3rd power minus 7. This time you're going to notice that the cube root goes over the x plus 7, all of it. So since it goes over all of it, I get to cancel it out with the power 3 and just say, oh, x plus 7 minus 7. And the 7's cancel out, which leaves me with x. So now I must go through and do it the other way as well. So now I'm going to take the top one into the bottom one. So I have cube root, and then inside the cube root, I have x to the third power minus 7 plus 7. Minus 7 plus 7, they cancel out. And then cube root and power 3 cancel out, so I get x. Since they both simplify down to x, I get to say, yes, they are inverses. Okay, last question. Okay, I give you the graph, and on this one, we want to answer the questions off to the side. So when I look to the statements off to the side, the first one you're going to notice says h of 4. That does not have a little -1 power. So that's the regular graph. That's not the inverse graph. That's just the regular graph. So basically, I'm telling you the x number is 4. You tell me the y number. So go on your graph, find 4, follow it till it hits my dot, and then follow it across, and you'd say, oh, well, the y number is 1. Now, the next ones, you're going to notice that they have the inverse symbol. So let's go back here to my graph, and let's make a conclusion. Okay, this point down here at the bottom, on the red line, it is 0, -5. And then when I reflect it over on the blue line, I have the point -5, 0. So what can I say about those 2 points? Well, does everyone notice that I just flipped the x and y numbers? So if I take the red ordered pair and I flip it over, I get the blue one. So the inverse just ends up flipping it. So since this one has a little power of -1, I'm no longer giving you the x number. I'm giving you the y number, because remember, we had to flip it, and your job is to find the x. So I'm going to go to y is 0, which is right in the middle. And then, I will touch. So if I draw a horizontal line through the middle, I touch my graph in 1, 2, and 3 spots. So this problem is going to have 3 answers. So the farthest left is -3. The one in the middle is 0. And then the one on the right, I'm going to have to estimate it. And to me, it looks like about 2.5. Okay. Next one. It also has a little power of -1. So that's an inverse. So remember, if it's an inverse, it's a y number, not an x number. Okay, so that's a little easier to see. I'm going to go up here and erase some of these. All right, y number is 1. So if I draw a line across here, my y number of 1, you're going to say, oh, well, that actually touches my graph 3 times as well. I've got this point, and this point. So if I start with the one farthest on the left, that's going to be a decimal, so we're going to have to estimate that one to the best of our ability. So I'm going to say about -3.8. Then we have -1 and +4. Okay, last one. On the last one, once again, it has the inverse of -1, so that's a y number I'm giving you. Your job is to find the x number. So on the y, go to 3. And that one only touches my graph 1 time. And the x number for that is -5. Done.